Hello, so today we are going to do this Leetcode day 24 problem. The problem is called jump game, and the problem says given an array of non-negative integers, you are initially positioned at the first index, and each element in the array represents the maximum jump length at that position. And we want to determine if we are able to reach the last index. So 2 here means that we can jump 2 positions, so we could jump I think all the way until this one, and then we can jump once again, and then we can jump to 4, so we should return true. Here, well, we could start from 3, and so 1, 2, 3, jump to 0, and then we can't jump anymore. But here that's the maximum jump, so we can jump just, so you'll always arrive at seems like even if we jump only until 1, well, we jump until 0 and we are stuck, or we just jump until 2 and from 2 we'll end up at 0. So no matter what, we'll end up at 0 and we can't move from there. So we should return false here. So, well, one solution is just try all of them, right? Just at this position, for example, try jumping 1 position and 2 positions. So try from 1 to the value and see which one gives us the answer, right? The only thing is there may be some redundancy. Like, let's say you arrive here with either coming from here or coming from here, the result would be still the same. So maybe if we have some kind of function with the state that says the position, would that be enough? So you are at this position. I think that would be enough, right? And for each one, we just try for I in 1 to the value, which is nums at I, right? Let's try this one. Let's see if that one gives us what we are looking for. So if I have helper here that goes up until I, and then say helper for 0, right? So we say if I is equal to the length of the list of numbers, we can return true, right? That's the last position, so we arrived there. Otherwise, here we are going to say in range 1 all the way until so this should be j, right? So we're going to call, and then if this is and then otherwise return false. And this should be j. We will need maybe to memorize, but let's just first make sure it works. Yep, we should start from I plus 1, right? No, not really, actually. What I'm doing here is wrong. So it's 1, and we want to do I plus j, right? Because that's the current position. We want to jump. Okay, let's see. Okay, that looks good. So let's just have some memorization here. So we need a map, and we will need to put So here we'll need to do this, right? And then just return it. And we'll need to do a similar thing here. And we'll need to say if I in memo, we'll just want to return it. And I think this should do it, right? Let's try to submit. We can probably use any here if this works, but we have time limit exceed. Yep. So this is not that efficient. So maybe there is some redundancy here. So actually one thing is, what can we, like, if you can't reach with one, or can't reach, let's say, with, so if the value is bigger than the difference between the length, then we shouldn't try it, right? So that's one optimization we can do here is if, let's first just put this in n. So here, if j is bigger than, if I plus j, right, is bigger than n, or even equal, then there is no chance of reaching, right? So you should just break or just return false right away. So that would mean here we'll need to set it first. Okay, so still time limit exceeded there. Maybe it will be faster to try bigger jumps. Could definitely do that. So we could say start from this here, right, and try to go down until 0, which means we'll go down until 1. Okay, I think this is getting complicated and it's not passing, so let's try just a linear approach. I think we could just, okay, let's first just put the length in a variable. And then let's start with I, that starts at 0. And then let's just keep a variable which just keeps track of the maximum reach. And that's as starts at 0. And then we want to say, well, I is less than n, we want to keep incrementing I, move it by 1. But what is the maximum reach now? So the maximum reach is the max of the current position plus whatever you can jump by and whatever was in the value before. Because if the, let's say, a cell has value 0, we want to we don't want to take 0, right? We want to take the max, which is just I, right? And here we don't want I to be incremented beyond the reach, right? Because if the value is 0, you don't want it to move. And then here at the end, we want to just make sure that we reach the end. And so if I run this, submit. Okay, so that's accepted, yeah. So that's pretty much it. This is linear, so it's pretty fast. Yeah.